All right, everybody, gather round. Thanks for being here. Today, we're kicking off our complete job site safety masterclass, explaining OSHA 1926 Subpart X. I'm out in the field every single day, just like you, and I can tell you straight up, this standard is literally the most critical playbook you're going to use today. We're not just here to check a compliance box for the front office. We're breaking down the real, practical standards for stairways and ladders on our sites. The whole goal? Making sure every single one of us walks off this site and goes home to our families exactly the way we showed up. Okay, let's dive into this and face a pretty grim reality right out of the gate. 160. That's roughly the number of construction workers in the U.S. who lose their lives every single year from ladder-related incidents. Think about that for a second. 160 of our brothers and sisters in the trades, folks who just went to work, climbed a ladder, and never came home. It is a staggering number, right? And the most frustrating part? It's almost entirely preventable.
And look, the danger doesn't stop at fatalities. On top of those tragic losses, we see about 25,000 workers suffering serious, life-altering injuries every single year. We're talking shattered bones, traumatic brain injuries, permanent spinal damage, the kind of stuff that ends careers instantly. In fact, if you look at the data, falls from ladders make up about a third of all construction fall fatalities. When you put it into that perspective, it's a no-brainer why ladder safety absolutely demands our undivided attention before anyone steps foot on a rung.
So, this brings us to the actual foundation of what we're explaining today, OSHA 1926 Subpart X. Now look, I know what happens when some folks hear OSHA standard. The eyes roll, right? You're thinking it's just a bunch of red tape and bureaucracy holding up the job. But we need to flip that mindset right now. Subpart X isn't paperwork, it's a life-saving tool. It spells out the strict performance requirements, the proper selection, the safe use, and the mandatory maintenance of our gear. It's the playbook. Every supervisor, every foreman, and every worker on this site has got to respect this standard. Because when we ignore it, we're not just risking a fine, we're risking lives.
A huge chunk of getting Subpart X right comes down to simply having the right tool for the job. And that means you got to understand ANSI duty ratings. Look at this breakdown. At the top, you've got your type IA. These are the special duty ladders built for heavy industrial work holding a massive 375 pounds. Right below that, the type IA extra heavy duty at 300 pounds. That one's your bread and butter for commercial construction. Then we step down to the type I heavy duty at 250 pounds and type 2 medium duty at 225. Now, pay attention to this last one, the type 3 light duty ladder. It maxes out at 200 pounds and is made for, painting your living room or hanging Christmas lights. Let me be perfectly clear. Type 3 household ladders are strictly prohibited on our commercial job sites. If you bring one from your garage to this site, it's going straight into the dumpster. No exceptions.
So the crucial point here is understanding exactly how to calculate your weight on that ladder. We call this the weight math, or the maximum intended load. OSHA says you can never, ever load a ladder beyond its duty rating. And hey, it's not just about what the bathroom scale says when you step out of the shower. You've got to use the rule of 3. That's your body weight, plus the weight of your heavy tool belt and PPE, plus whatever materials you've got in your hands. So if you're a 200-pound guy wearing a 30-pound tool belt and hauling up a 25-pound bucket of mud, congratulations, you're at 255 pounds. You literally just exceeded the legal limit of a 250-pound type I ladder. You'd need an extra heavy-duty type IA for that task. Always do the math before you climb.
And honestly, this brings up a really clear divide between the seasoned pros and the rookies out here. The common rookie mistake, and we see it constantly when guys are rushing to beat the clock, is just grabbing the nearest ladder off the truck to save a couple of minutes. They don't check the rating, they just want to get up there and get it done. Don't be that guy. The pro tip: a true professional always checks the ANSI duty rating label on the side rail before climbing. It takes, 3 seconds? Just 3 seconds to verify the maximum working load capacity and prove that ladder is actually rated for what you're about to do. Never climb a mystery ladder. If that tag is missing or you can't read it because it's covered in drywall mud, treat it as a massive red flag. And this brilliantly illustrates what we're talking about when you actually inspect that gear. When you do your mandatory pre-use inspections on a standard extension ladder, OSHA requires you to look for visible defects before every single work shift. Not just once a week, every shift. As a supervisor or a competent user, you need to literally run your hands and eyes over those side rails. You're looking for cracks, splits, or bent edges. You check the rungs to make sure they aren't loose and absolutely ensure they're free of grease, oil, or mud. Nobody wants a slippery rung. You got to inspect the rope and pulley system for any fraying, check the rung locks to make sure they aren't cracked, and verify that those anti-slip safety feet at the base are fully intact. Now, a little normal wear and tear, Sure, that's expected. But structural damage, that is an immediate deal breaker. Part of your training under Subpart X is hazard recognition. I really want to paint a vivid picture for you of the most common, dangerous violations we catch in the field. First off, standing on the top step or the top cap of a stepladder. Guys do this all the time to get just a couple extra inches of reach, and man, it is a massive OSHA violation and insanely dangerous. Second, overreaching. The old belt buckle rule. If you have to lean so far that your belt buckle goes past the side rails, your center of gravity shifts and boom, you're going down. Just climb down and move the ladder. Third, setting ladders on unstable garbage like boxes, uneven dirt, or slippery floors instead of a solid, level base. And finally, using aluminum or metal ladders anywhere near electrical work or live power lines. Metal conducts electricity, folks. Always use fiberglass if you're doing electrical work. All right, there is a crucial rule I want you to treat like it's tattooed on the back of your eyelids, the 3-point contact rule. When you're going up or down that ladder, you must have 2 hands and 1 foot, or 2 feet and 1 hand securely on the ladder at all times. Period. Now, think about this logically. If you're carrying a heavy drill in your left hand and a bucket in your right hand, how many points of contact do you actually have? Just your 2 feet. You've completely broken the rule. And this is exactly why OSHA requires you to use tool belts to keep your hands free, or to use a rope and hoist system to pull your materials up once you safely reach your working level. Let's move to how this builds directly into the legal responsibilities of our site supervisors and foremen. Listen up, leaders. Under Subpart X, the competent person on site bears a really heavy burden. Number 1, you are legally required to ensure ladders are inspected before every single work shift. Number 2, if a ladder is cracked, bent, or missing hardware, you don't just lean it back against the wall for the next guy. You must immediately withdraw it from service and physically slap a do not use tag on it or destroy it so nobody else can accidentally use it. And number 3, it is your duty to train the crew. If your workers can't explain load ratings to me, or they don't know proper setup and hazard recognition, your site is vulnerable, and frankly, you're failing as a leader. So, let's say you've done everything right. You've checked the duty rating, you've done the math on your maximum intended load, and your supervisor has thoroughly inspected the gear and said it's good to go. The foundation is totally set. But what happens once the right ladder is chosen and inspected? How do we actually place that extension ladder against the building to guarantee it doesn't just kick out from underneath us the second we step on that first rung?
All right, so wrapping up our walkthrough on stairway requirements, let's just go ahead and pivot to the next major hazard we deal with on our sites: portable ladders. Now, ladders are one of those tools that just get taken for granted, right? We use them at home to clean the gutters, we use them on the site to get to a working level, and because they're literally everywhere, ladder safety gets exactly zero consideration, right up until something goes terribly wrong. Well, in our line of work, we cannot afford zero consideration.
According to the CDC, looking back at the first 10 years of this century, falls from ladders made up an unbelievable 43% of all fatal falls. 43%. Just let that sink in for a second. We're talking about nearly half of all fatal falls involving a tool that almost every single one of your workers uses every single day. We've lost hundreds of lives because of a piece of equipment that seems so simple, people just forget to respect it.
And for us in construction specifically, the numbers get even more grim. Ladders were involved in a massive 81% of all treated fall injuries in our industry. 81%. That means if one of your guys is heading to the clinic or the ER today because of a fall, it is overwhelmingly likely that a ladder was involved. This isn't just some minor hazard we can brush past. This is the primary source of fall injuries on your job site right now.
Let's dive into the true cost here, because we aren't just talking about statistics on a spreadsheet. These are guys who didn't go home to their families. I investigated a site a few years back where a guy fell just 8 feet off an unsecured ladder. Just 8 feet. It resulted in a traumatic brain injury that ended his career right there on the spot. Those who do survive these falls often deal with severe spinal cord damage and shattered bones. And for the business? Well, it means crippling project delays, massive workers' comp claims, a totally damaged reputation, and OSHA face fines up to $145,000 for repeated or willful violations.
Now, OSHA knows these injury stats inside and out, which means portable ladders are constantly in their crosshairs. Year after year, right up through fiscal year 2024, the Portable Ladder Standard, 1926.1053, is the third most cited standard across all construction operations. If an inspector walks onto your site today, I guarantee you they are looking at exactly how your crews are using ladders.
So let's break down these top violations, because as supervisors, knowing exactly what OSHA is citing, that's your literal roadmap for your morning site walks. The data shows clear failure modes. We're seeing side rails coming up short, guys using ladders for the wrong purpose, folks standing on the top step, workers carrying heavy tools while climbing, and failing to tag out defective equipment. These root causes right here, these are the bad habits your crews are getting into every single day on the ground.
The most crucial point is this first one. The number one ladder violation, we're talking over 1,800 citations in 2024 alone, is guys using ladders that are simply just too short. The standard absolutely mandates that the side rails of a portable ladder must extend at least 3 feet above the upper landing surface. When guys grab a ladder that's too short, they end up stepping blindly onto the roof of the landing. And that transition, that is exactly where the fall happens. Now, if they can't get that 3 feet, the ladder must be secured in a grab rail provided, but honestly, the absolute easiest fix is just getting the right-sized ladder to begin with.
Then, you have the top step trap. Nearly 300 citations were handed out for guys standing on the top step, or the top cap of a step ladder. We've all seen it, right? A worker is trying to cheat the height to gain just a little bit more reach, but that top step is not designed for standing. It completely removes your ability to balance against the side rails. Let me be blunt. Seeing this on your site is a massive red flag. It means you've got a training gap, and it means poor job site pre-planning because the right equipment wasn't provided for the task at hand. Listen, we've got to stop accepting these daily compromises. You absolutely cannot have guys carrying tools in their hands while they climb. Carrying materials breaks the 3 points of contact rule, which means if they slip, they have literally zero way to catch themselves. The pro tip here is super simple. Mandate the use of tool belts, or better yet, rig up the simple pulley system with a bucket to hoist tools up once the worker is tied off and secure. And another lazy habit? Using a closed step ladder leaned against the wall. That completely violates the manufacturer's design. Don't let your guys be too lazy to go grab the proper straight or extension ladder.
Here's a great memory trick to teach your crews, the belt buckle rule. It's super easy to remember. If you're up on a ladder and your belt buckle goes past the outside of those side rails, you are overreaching. OSHA identifies overreaching as a leading cause of ladder falls simply because it drastically shifts your center of gravity and kicks the ladder right out from under you. If a worker has to stretch to reach their work, they need to climb down, move the ladder, and climb back up. Period.
Then we have the basic physics of a proper setup, the 4-to-1 rule. For extension ladders, you have got to aggressively enforce this ratio. For every 4 feet of working height up to the point of support, the base of the ladder needs to be exactly 1 foot away from the wall. If it's too steep, the ladder falls straight back on you. If it's too shallow, the bottom kicks out, or the ladder just bows under the weight. It's a really simple visual check, but it guarantees stability.
And honestly, setup matters just as much as the condition of the ladder itself. OSHA strictly prohibits setting up ladders on boxes, barrels, or any other unstable bases just to gain a few extra inches of height. Ladders have to be used on stable and level surfaces, unless they're properly secured to prevent accidental displacement. I mean, setting up in the mud or on a slick floor without securing the ladder, that is just asking for an ambulance. Oh, and check their boots. Shoes need to be totally free of mud and grease before they even touch that first rung. Industry veteran Richard Dixon puts it perfectly. There is absolutely zero excuse for using a damaged ladder. Before every single shift, these things must be inspected for visible defects. We are looking for cracked rails, loose rungs, missing feet, corrosion. And let me be perfectly clear, makeshift repairs with duct tape or scrap wood are strictly prohibited and completely unacceptable. If it cannot be repaired to manufacturer specifications, it's done. Get rid of it.
This right here is exactly why your site needs a formalized, competent person for ladders. And I don't just mean a title you throw at some guy on Tuesday. It requires specific training and, most importantly, explicit authority to stop work. When they do their daily inspections, if they find a structural defect, they must immediately mark it "Do Not Use." But honestly, in the field, just tagging it isn't always enough. A strong, competent person will physically destroy that bad ladder, literally cut it in half so no one else gets the bright idea to pull it out of the dumpster and use it anyway.
So let's look at how you build this into your daily supervisor practices. As a foreman, you can actually engineer out a lot of these hazards before the dirt even gets moved. Standardize your inventory to heavy-duty, non-conductive, type IA or type AA fiberglass ladders. This eliminates the risk of electrical conductivity entirely, and it ensures the ladders handle heavy dynamic loads. Also, verify your ladder heights during phase pre-planning so guys aren't stuck with a 6-foot ladder for a 10-foot job. And implement digital daily briefings where guys physically check off that pre-use inspection before they ever start work. Also, keep in mind that hazard recognition training, it is not a one-and-done deal at orientation. Under the standard 29 CFR 1926.1060, you are legally required to retrain your crew. Now, when does this happen?
the moment job site conditions change or the very second you spot unsafe behavior. If you see a guy violating the belt buckle rule or carrying a drill in his hand up an extension ladder, that is your trigger to stop work and conduct retraining right there on the spot.
I want to leave you with this thought today. If a ladder setup feels like a compromise, it probably is. Think about the ladders sitting on your site right now, literally this very minute. Are you letting your guys compromise just to save a few minutes, or are you aggressively enforcing the standard to save their lives? Keep that in mind. All right, let's see how much of this you've retained as we move right into our hazard recognition recap quiz.
All right, so you've got that 4-to-1 extension ladder setup ratio completely dialed in. The base is perfect, the feet are totally secure, the top is extending a clean 3 feet past the landing, and everything is tied off exactly as it should be. It looks great, but now comes the real moment of truth, right? You actually have to put your boots on the rungs.
And I'll tell you right now, as someone who has spent well over 20 years on actual construction sites, the safest ladder setup in the world means absolutely zero if your crews don't understand the physical mechanics of a safe climb. Seriously, you can have a brand new, extra heavy-duty Type 1A ladder pitched perfectly, but if your behavior on the way up is reckless, gravity is going to win. Every single time. So, the setup is done. Now we climb. Let's dig into the exact mechanics of how we actually control our ascent.
Take a look at this side-by-side comparison because it brilliantly illustrates your absolute baseline for survival on any job site. We're talking about the 3 points of contact rule. This is the fundamental behavioral control for climbing. Notice how at every single second of movement on that ladder, the worker maintains either 2 hands in 1 foot or 2 feet in 1 hand, firmly engaged with the equipment. You've got to think of it as a constant physical contract between you and the structure. Break that contract, and well, you're just inviting disaster.
Let's actually look at the exact letter of the law here in OSHA's climbing protocols. When ascending or descending, you must face the ladder. Not sideways and definitely not looking over your shoulder to talk to a buddy about what's for lunch. Face it. Keep centered and always grasp the ladder with at least one hand when progressing up or down. That is a mandatory grip, folks. It's not a suggestion. It's the required ergonomic control you need to keep yourself attached to those rails if your boot happens to slip.
Section 1. The physics of balance and staying centered. What's really fascinating here is that we're moving past just memorizing OSHA rules and getting into the actual physical science of why those rules even exist in the first place. See, a ladder is engineered to carry vertical loads. It expects your weight to pull straight down through those side rails directly to the ground. Your center of gravity is exactly what dictates whether that ladder stays upright and stable or violently kicks out right from under you. So, the crucial point is how you control that center of gravity. Out in the field, we teach a really classic, simple trick for this. It's called the belt buckle rule. As you can see right here in this slow motion sequence, you want to keep your body's midline, your belt buckle, strictly between those 2 side rails at all times. If your belt buckle crosses over the rail, you are no longer centered, period. It's just a fantastic instant visual cue for you and honestly for anyone watching you climb to know if you're actually working safely. Because when you violate that rule and lean past those side rails to, say, reach a tool or hammer a nail, you shift your lateral center of gravity way outside the boundary of the ladder, and that introduces some really dangerous torsional forces, twisting forces, that the equipment was absolutely not designed to handle. That twisting destabilizes the ladder and boom, it tips. So here's your pro tip. If you can't reach it with your belt buckle centered, climb down, move the ladder, and reset. Never, ever stretch for it.
Section 2. The hazards of the haul. Now, breaking that 3-point rule usually builds right into the most frequent and frankly most dangerous job site violation I see on a weekly basis. And usually it's just because someone decides their hands need to hold a circular saw, a heavy bucket of mud, or even their morning cup of coffee instead of the rungs.
Listen to the standard directly on this one. An employee shall not carry any object or load that could cause the employee to lose balance and fall. That is a hard, very clear regulatory line from OSHA. Hauling heavy tools or materials in your bare hands while climbing is a direct, serious violation. You simply cannot maintain a firm, safe grip with 2 hands if one of them is busy lugging a cordless drill all the way up to the roof.
And hey, if you think inspectors aren't actively looking for this, just look at this number, 92. That is the hard statistic of actual citations OSHA handed out in fiscal year 2024 specifically for workers carrying loads that caused a loss of balance and violated that 3 points rule. That's 92 times a safety inspector watched someone risk a devastating, completely life-changing fall, all just to save a couple of seconds carrying something up by hand.
So what do we actually do about it? Well, you have to provide practical, real-world alternatives for moving materials vertically so your workers aren't even tempted to sacrifice their grip. Step 1, put on a tool belt. It keeps your hands completely free for small items. Step 2, for heavier materials, set up a hoist, use a pulley system with a bucket, or rig up a simple tagline. And Step 3, climb with empty hands, always. Your hands have one job on that ladder, and that is holding on to the rungs.
Section 3, Supervisor Enforcement and Training. Now, for the foremen and safety managers listening to this, I'm talking directly to you right now. The responsibility for enforcing these climbing rules falls squarely on your shoulders. You're the ones who set the tone out there. It's your job to create a job site culture where doing it right is literally the only way it gets done, and that always starts with proper education.
Because OSHA strictly requires employers to provide a comprehensive training program. Every single crew member using a ladder has to be trained by a competent person. They need to thoroughly understand the nature of fall hazards in your specific work area. They absolutely must know the proper use, placement, and maximum load capacities of the ladders they're using, right along with all the general Subpart X standards we're covering. Oh, and remember, you must document that training. If it isn't on paper, it didn't happen.
Here is a mentor-level pro tip for you supervisors out there. Correct the behavior, not just the ladder. Look, we all know daily pre-use ladder inspections are absolutely vital. Checking for cracked rails, loose rungs, missing feet, the whole shebang. But your job does not end when you tag a bad ladder out of service. You need to actively watch your crew climb. If you see someone carrying a heavy load in their hand, stop them. If you see a belt buckle drifting outside the rails, you correct it in real time. That active daily field mentorship is what actually saves lives on a job site.
So I want you to evaluate your own site today. Just ask yourself, if I walked onto your job site right this very minute, would I see your crews climbing with empty hands? Would I see their belt buckles perfectly centered between those rails? Take a really hard look at your team. If the answer is no, well, you have some immediate work to do before a simple, routine climb turns into a permanent tragedy.
Now, obviously, everything we've just discussed applies perfectly to straight and extension ladders. But what happens when we completely change the geometry and introduce A-frame step ladders? That shift in structural design introduces a whole new set of kinematic rules, stability limitations, and fatal mistakes. So are your crews truly ready to step off the straight ladder and onto an A-frame safely? Let's dive into the mechanics of A-frame step ladders and find out.
All right, let's keep things rolling. Straight into part 2, setup and the 4-to-1 rule.
So we've got the right duty rating and ladder type picked out, right? Now we need to dive directly into the physical setup. Because listen, having the toughest, highest rated ladder on the site won't do you any good if it's positioned wrong. In my 20 years walking job sites, I'll tell you right now, setup is where the vast majority of incidents actually start. Check this out. There are 2 absolutely critical dimensions highlighted here for a safe setup, extending those side rails at least 3 feet above your upper landing and perfectly angling the base. Under OSHA Subpart X, these aren't just polite suggestions, they're the literal geometric foundation for keeping your crew upright.
Okay, so let's break down that angle calculation, which brings us to the famous 4-to-1 rule. This rule is the absolute bedrock of your safety. It's a simple, non-negotiable ratio that ensures gravity is working with you, not against you. And spoiler alert, gravity always wins, so we really have to do the math here. If you're climbing 20 feet up in vertical height to reach a roof, the base of that ladder needs to be placed exactly 5 feet away from the wall. 1 foot out for every 4 feet up. It really is that straightforward.
Now here is the exact math behind that rule. When you nail that 4-to-1 ratio correctly, you're creating an optimal 75.5-degree angle. Extensive engineering data proves this is the exact sweet spot for balancing a worker's load while climbing. At exactly 75.5 degrees, the downward force of your weight is perfectly distributed between the structure you're leaning on and the ground below you.
But what happens when you miss that sweet spot on the job site? Well, the dangers become obvious pretty fast. Say you set it too steep, meaning an angle greater than 78 degrees. Your center of gravity shifts outward as you climb. Lean back just a hair, and boom, you tip backward, taking the ladder right with you. On the flip side, if the angle is too shallow, less than 73 degrees, lateral forces skyrocket. They actually overcome the friction on the ground, and that base just kicks right out from under you. Both of these scenarios end in a catastrophic fall.
As foremen and supervisors, I need you training your crews to mechanically run through these exact 4 steps every single time they position an extension ladder. Step 1, level and firm the base. Step 2, set that 4-to-1 working angle. Step 3, get those side rails extended 3 feet above the landing. And step 4, secure the top support. If you can build this muscle memory into your guys, you're eliminating the majority of ladder hazards before anyone even puts a boot on the bottom rung.
Let's zoom in on step 1 for a second. This requires those slip-resistant feet to be placed on a firm, perfectly level surface. Look at how these heavy-duty feet are positioned. You never, ever prop a ladder up on boxes or barrels or muddy slopes just to cheat an extra foot of height or deal with a weird grade. The ground underneath those feet has to be absolutely rock solid, or frankly, all the careful angle math in the world isn't going to save you.
Take a look at this real job site photo and ask yourself, would you let your crew climb this? It's resting on loose, uneven dirt right next to what looks like a trench layout. This is a massive, massive hazard. The surface is neither level nor firm. The second a worker gets halfway up, their weight is going to shift that left foot right into the loose soil, twist the ladder, and throw them right off.
In my time walking sites, I see these exact same setup mistakes happening every single day. Why? Usually, it's just guys rushing and skipping the basics of 1926 Subpart X. They eyeball the angle instead of actually measuring the 4-to-1 ratio. They set up on slippery or unstable dirt. They skip tying off the top because, they're just going up for second. They carry heavy tools in their hands instead of using a tool belt or a hoist, and they overreach to get the job done faster.
Speaking of overreaching, here's a great field trick to keep in your back pocket to avoid that specific mistake: the belt buckle rule. It is incredibly simple. If your belt buckle crosses outside the vertical side rails of the ladder, you've shifted your center of gravity way too far. Stop, climb down, and move the ladder over. Seriously, it takes maybe 30 seconds to reposition, but stretching to save that half a minute is a leading cause of lateral tip-overs.
And OSHA Regulation 1926.1053 is crystal clear in its text. If you literally cannot find a perfectly level and stable surface, say you're working on a sloped grade that you just can't level out, that ladder must be mechanically secured to prevent accidental displacement. You can't just have your buddy hold the bottom while you climb 30 feet up. It absolutely has to be properly secured.
Securing the top of the ladder to a rigid support that won't deflect is just as critical. Sometimes you're stuck in a spot where the ladder is just too short to safely get that mandatory 3-foot extension above the landing surface. In that specific scenario, the OSHA standard dictates that the ladder must be secured at its top to a rigid support, and you have to provide a grasping device, like a grab rail, to help the worker mount and dismount safely.
Look, ignoring these setup rules isn't just dangerous, it's a massive liability for your site. Ladder violations were the number 3 most frequently cited OSHA violation across all industries in fiscal year 2024, with thousands of citations issued. And specifically, failing to extend those side rails 3 feet above the landing, that accounted for the lion's share of them. It's a super common oversight, and inspectors are actively hunting for it.
Want to know what that oversight costs? If an inspector catches a serious 1926.1053 violation on your watch, like missing that 3-foot extension or totally ignoring the 4-to-1 angle rule, you're looking at a maximum fine of $16,550 per offense, based on the 2025 penalty schedule. And that's just the baseline for a serious violation. If they deem it a repeated or willful violation, those numbers just skyrocket.
Ultimately, that financial and moral accountability falls squarely on you, the supervisors. You have to ensure a competent person is thoroughly inspecting every single ladder for visible defects before a work shift even begins. That means physically running your hands down the stiles looking for cracked rails, checking for loose rungs, missing slip-resistant feet, and making sure the whole thing is completely free of oil, grease, or any slipping hazards. Inspection isn't a nice-to-have, it's a fundamental requirement.
Now, if you do that inspection and find a cracked fiberglass rail, a bent aluminum rung, or missing hardware, what do? I'll tell you what you don't do. Temporary duct tape fixes. There are absolutely no field repairs like that allowed. None. You must immediately tag that ladder do not use and pull it from service until it's properly repaired to its original design specs or totally destroyed. Leaving a busted ladder leaning against the wall is practically begging someone to use it and get hurt.
All right, so the equipment is perfectly set up. It's fully inspected, sitting firmly on level ground at a perfect 75.5-degree angle, extended 3 feet above the roofline and locked in securely at the top. The physics of the ladder are completely optimized, which means the only remaining variable for a safe ascent is exactly how you position your hands and feet once you step onto that first rung. Let's look at exactly how to do that.
All right, let's keep the momentum going with our ladder and stairway safety masterclass, where right now we're focusing on step-ladder operations. We just spent some really good time breaking down that 4-to-1 ratio and mastering the vital 3 points of contact rule for extension ladders, but I want to throw a question out to the crew. how exactly do we apply those exact same safety principles to what is, without a doubt, the most misused piece of equipment on any construction site? I'm talking, of course, about the A-frame stepladder. So let's dive right into this. Now, you might be wondering how the three-point rule fits in here. What's really interesting is that even though a stepladder is self-supporting, meaning you don't have to lean it against a wall, that three-point rule absolutely still applies. You still need 2 hands and a foot, or 2 feet and a hand, firmly locked onto that structure as you climb. But because of its unique design, the stepladder brings a whole new set of OSHA 1926 Subpart X hazards and rules to our job site. It's engineered perfectly for vertical loads when it's fully extended, but let me tell you, it is notoriously unforgiving if you push its limits. So, before you even think about putting a boot on that bottom rung, we have to talk about inspections. Under OSHA 1996.1053, a competent person has to inspect ladders on a periodic basis. But frankly, workers need to be checking them for visible defects before every single shift. We are looking for cracked or split rails, loose rungs, missing non-slip feet, and we absolutely have to ensure we're setting it up on a stable, level surface. If you find a defect, what do? You withdraw it from service immediately and tag it Do Not Use. Skipping this one simple step led to 86 specific OSHA violations just last year. That is 86 times an inspector caught a defective ladder just sitting around, waiting to injure someone. Don't let that be on your site. And this right here brilliantly illustrates one of the most critical structural components of the A-frame. Take a close look at the metal spreader bar on the screen. OSHA strictly requires that every single stepladder have a metal spreader or locking device to hold the front and back sections in an open position. Here's a pro tip for the field. Never, ever climb until you physically verify those spreaders are fully pushed down and locked into place. If they're slightly bent or, if the hinges are just packed solid with drywall mud and won't lock out fully, that ladder is out of service, period. Okay, this brings me to a habit I see out in the field all the time, and it drives me crazy. Never, ever use a closed stepladder leaning against a wall like an extension ladder. When you do this, you completely destroy its lateral stability. You see, the rubber feet on a stepladder are angled to grip the floor specifically when it's open as an A-frame. When you lean it closed, only a tiny little edge of hard plastic or metal actually touches the floor, making a slide out almost guaranteed. OSHA cited 310 violations last year for using ladders for purposes other than what they were designed for, and using a stepladder as a straight ladder is exactly the kind of shortcut they're looking to catch. Let's break down the physical kinematics of safe positioning when you're actually up there working. Always face the ladder whenever you climb up or down. And here is a fantastic memory trick you can teach your crews. We call it the belt buckle rule. Keep your belt buckles centered right between those side rails at all times. Do not overreach. If you lean your belt buckle past that side rail, your center of gravity shifts completely outside the footprint of the ladder, and gravity is going to take over. Also, never straddle the front and back sections. And please, whatever you do, don't ever try to walk or hop the ladder while you're standing on it. Just climb down, move the ladder, and climb back up. It takes 10 seconds, and it could literally save your career. Remember that 3 points of contact rule we talked about? Well, how exactly are you supposed to maintain it if your hands are full of drills and conduit? You can't. Carrying tools or loads in your hands while climbing totally destroys your balance and stability. This is an explicit OSHA violation, specifically 1926.1053b22, and it was cited 92 times last year. The solution here is so simple. Just wear a tool belt, or use a hoist line to pull your materials up once you're safely in position. All right, listen up, because the most crucial point of the day is right here. I need everyone to mentally highlight this OSHA standard. 1926.1053b13 states, the top or top step of a stepladder shall not be used as a step. This is the most critical warning of this entire field lesson. Absolutely no standing on the top cap and no standing on the step directly below it. I know the temptation is huge. You just need to reach that one last screw. You just need a little extra height. Actually, scratch that. Just don't do it. Go get a taller, correctly rated ladder. Let me explain the why behind this rule, because understanding the actual mechanics might just save your life. It creates a kinematic tip-over hazard. When you stand on those top 2 steps, you raise your body's center of gravity way above the safe pivot point of the ladder. Below that point, your weight pushes the ladder firmly down into the ground, stabilizing it. But above that point, any slight movement, just reaching for a tool or turning your shoulders, turns your entire body into a lever that pushes the ladder right out from under you. It physically turns a perfectly stable tool into a deadly tipping hazard. If you think OSHA inspectors don't notice this stuff, just look at this hard data right here. 286. There were 286 annual violations specifically for standing on the top step of a stepladder. Inspectors are actively hunting for this exact dangerous habit because they're the ones who have to investigate the traumatic brain injuries and shattered ankles that happen when these ladders tip over. Supervisors, listen to me. If you see a worker's knees resting against the top cap of an A-frame, you know instantly they are standing way too high. Stop work, get them down, and get a taller ladder.
And that brings the responsibilities straight back to the folks running the job sites. Under 1926.160, foremen and supervisors have a strict OSHA mandate. You've got to ensure every single employee using these ladders is trained by a competent person. And it's not just about telling them how to climb up and down. You have to teach hazard recognition. You need to train your crews on how to spot a bad setup, how to verify those spreaders are actually locked, and how to read and enforce the maximum load capacities. And remember, retraining is required whenever you see these bad habits creeping back onto your site. Document it, enforce it, and make it a non-negotiable part of your daily safety culture.
Well, let's see how these principles build into our next critical area of focus. We spent a lot of time today on portable ladders. You know, the extension and A-frames we carry all around the site. But as our construction projects advance, we increasingly rely on permanent, fixed ladders that are bolted directly to the structures around us. And it begs a really important question for anyone navigating a job site. Are those permanent, heavy-duty metal structures you rely on to climb hundreds of feet in the air truly as safe as you assume they are? Or do they hide an entirely different set of fatal flaws?
All right, so we just wrapped up those ground-level stepladder do's and don'ts. Let's conceptually pivot for a second. I want you to look up. We need to tackle the fixed ladders, permanently bolted to the buildings, towers, and structures on our job sites. Now, these things face constant environmental weathering and really heavy long-term use. Honestly, that makes them a completely different animal when it comes to safety and engineering.
But before we get into the exact measurements and the OSHA regs, we need to challenge a really long-held assumption out on the site. Do traditional metal cages actually catch a falling worker? For decades, we relied on those metal hoops, right? We thought they were our reliable safety net. I can't even tell you how many old-timers swore by them. But here's a surprising and frankly pretty brutal reality check. Modern biomechanical studies prove they absolutely do not catch you. If you slip, that cage isn't a safety net, it's basically a cheese grater on the way down. It turns your fall into a vertical obstacle course.
So if you're the competent person on site, you really have to understand the complex anatomy of these older, grandfathered cage setups. There are maximum intervals, staggered landing platforms, and very, very strict clearances that have to be maintained. Now, memorizing the entire code book for your daily field walk, yeah, that's tough. So I always teach my crews a super simple field memory trick to lock in the absolute most critical numbers you need to know.
I call it the 16-7-42 rule. And it starts, predictably, with the number 16. 16 inches is the absolute minimum clear distance required between the side rails of any fixed ladder. If you're out there inspecting a ladder and the width between those rails is less than 16 inches, it is an immediate no-go. Here is a super common worker mistake I see out there. Contractors try to save space, and suddenly you've got a worker wearing heavy winter gear, thick steel-toed boots, and a fully loaded tool belt trying to squeeze up this tiny ladder. I've literally seen guys get their tool belts wedged halfway up a climb. It's an ergonomic nightmare, and it totally prevents safe movement.
Next up in our rule is the number 7. And this number actually pulls double duty on the job site. First, you've got to maintain a minimum 7-inch clearance behind the rung. Why? Well, that's your boot space. Pro tip from the field here. Always look for conduit, pipes, or blockwork jutting out right behind the ladder. If there's an obstruction, a worker's boot can't fully engage the rung. Their foot slips, and bam, we've got an incident. Second, 7 is the minimum step across distance at the point of access. So when a worker steps off the ladder onto the landing, that gap needs to be between 7 and 12 inches. If it's any wider than 12 inches, OSHA steps in and requires you to build out a proper landing platform to bridge that dangerous gap.
And to complete our 16-7-42 rule, we land on 42. When your crew gets to the top of that grueling climb, you got to realize they are at their absolute most vulnerable point. They have to transition all their weight from the ladder onto the roof or platform. Those side rails, or the grab bars, they must extend at least 42 inches above the access level or landing platform. That 42-inch extension, non-negotiable. It gives your workers a secure, chest-high handhold so they can maintain that 3 points of contact, which, remember, we hammered home in the last section, while safely stepping off. Okay, so now that we have the physical dimensions locked in, let's talk altitude. The magic number for fall protection on a fixed ladder is 24 feet.
Under OSHA standards, if the total length of the climb equals or exceeds 24 feet, you absolutely must provide fall protection. But hey, here is an OSHA inspection insight that catches a ton of contractors completely off guard, even if the ladder itself is only, say, 10 feet long. If the top of that ladder sits more than 24 feet above a lower level, like imagine it's on a high retaining wall or right at the edge of a deep excavation, fall protection is still strictly required. It's not just about the length of the ladder itself, it's all about the potential fall distance.
And this brings us to a massive paradigm shift in safety science. The old way relied heavily on cages and wells. The new way? It relies on personal fall arrest systems, or PFAS, and active ladder safety systems. Remember those biomechanical studies we talked about? The ones proving cages are just a vertical cheese grater? Think about it. A worker who loses their grip inside a cage is going to brutally strike those metal hoops all the way down. They'll suffer severe impact injuries before they ever even hit the ground. But an active PFAS, like a self-retracting lifeline, a rigid rail, or a cable traveler system, that actually arrests the fall immediately. It keeps the workers suspended, intact, and most importantly, alive.
Because of those pretty brutal findings, OSHA changed the game with a phased rollout. If your site has a cage that was installed before November 19, 2018, it is currently grandfathered in. However, anything installed after that November 2018 date strictly requires a modern PFAS or ladder safety system. Cages are completely invalid as fall protection for any new installs. Now, I want you to take note of the recent 2026 update. Originally, OSHA had this hard deadline of 2036 to just rip out all the old cages. Well, the update removes that hard deadline, but the strict rule still remains. Whenever that old ladder reaches the end of its service life, or if you repair or replace a section of it, you must upgrade the whole thing to a modern fall arrest system.
That being said, I know a lot of you still have those grandfathered pre-2018 cages surviving on your industrial sites right now. And if your crews are still climbing them, you must enforce the 50-foot rule. For any fixed ladder that is still relying on a cage, OSHA requires landing platforms at maximum intervals of 50 feet. Look, climbing is exhausting work, plain and simple. If your guys are climbing 80 feet of caged ladders straight up without an offset rest platform, you've got a serious violation on your hands, not to mention a major fatigue hazard that could easily lead to a catastrophic fall.
So, as site supervisors, ensuring all of this remains compliant falls squarely on our shoulders. Your designated competent person needs to get hands-on periodically. You got to check the structural mounting to ensure the standoff brackets and base plates are actually secure. Here's another pro tip from the field. Always look really closely at the anchor bolts. They are almost always the first thing to rust out from harsh weather exposure. You'll want to inspect the side rails for any structural cracks. Verify that the rungs have a uniform 12-inch spacing on center, and if you do have a well or a cage, run a careful visual check to ensure there are absolutely zero projections inside, nothing that could snag a worker's harness or clothing during a climb. It's a thorough checklist, for sure. And honestly, if you and your competent person are out there doing these inspections correctly in the harsh job site elements, eventually you are going to find a problem. It might be a cracked weld, a loose bracket, or a bent rung, which naturally leads to a critical question for any foreman. What exactly happens when you spot a critical defect on a ladder bolted 40 feet up your building? How do we instantly isolate that hazard before someone tries to climb it on the very next shift? Well, let's keep things moving right into the exact protocol for defect tagging and withdrawal from service. Masterclass Section 6, Ladder Inspection and Defect Recognition. All right, we just wrapped up the strict requirements for fixed ladders and cages, right? Good, but now we really need to shift gears and talk about the equipment that gets dragged around the job site every single day. I'm talking about portable ladders. You know, you'd think because we use them at home to clean the gutters, we'd be total pros on the site. But honestly, that familiarity, that is exactly where the danger creeps in.
Look at this number, 43%. In the first 10 years of this century, a staggering 43% of all fatal workplace falls involved ladders. That's almost half, guys. Think about that. It's just an astronomical number for a tool that's supposed to be so simple. And listen, those aren't just the historical statistics. The stakes right now, today, are just as high. Every single year, we are still seeing about 160 ladder-related fatalities across the U.S. And that's not even mentioning the thousands of severe, life-altering injuries. We're talking traumatic brain injuries, shattered spines, the kind of stuff that ends careers. An uninspected ladder on your job site isn't just a piece of equipment. It is literally a ticking time bomb waiting for someone's boot to hit the wrong rung.
So, how do we prevent that? Well, it starts right here with a proper inspection. Every single shift, before you even think about climbing, you need to do a top-to-bottom sweep of the ladder's anatomy. Check the fly section, the base section, the side rails, and those rung locks. Get in there and inspect the rope and pulley systems for any fraying, and look really closely at the anti-slip safety shoes. If any one of these components is compromised, the whole system fails.
The secret here is making it a habit. This pre-used visual checklist should take you less than 60 seconds, and it absolutely must be done by every worker every single time they go to climb. Step 1, check for legible tags and weight ratings. Step 2, run your eyes over the rails and rungs looking for cracks or dents. Step 3, test the hardware. Make sure the spreaders actually lock and the hinges aren't loose. And Step 4, check the feet. Slick mud or worn-out rubber on the feet means you have zero traction on the ground.
Now, if you're still rocking wood ladders out there, you need to know how OSHA classifies timber defects. Let's translate their terminology into everyday field speak. Shake is a separation right along the grain that completely guts the shear strength of the wood. Wane just means you've got missing wood or bark on the edge, which shrinks your load-bearing area. Compression failures are those unseen buckles from overloading the ladder on a past job. And decay, well, that's just rot. Any of these mean that ladder is structurally compromised. But let's be real, most of you are hauling around fiberglass or metal ladders. With these, you're looking for different killers. Blooming is what happens when UV rays from the sun or chemical exposures degrade the fiberglass. It exposes these raw glass splinters underneath, and worse, it completely wrecks the ladder's electrical resistance. Watch out for structural deformation too, like bent side rails. And connection play? Listen, if you grab a rung and it wiggles or twists even a little bit inside the side rail, that connection is shot. That ladder's dead.
And supervisors, hear me on this. Makeshift fixes are absolutely never acceptable. You cannot duct tape a cracked fiberglass rail. You cannot bolt a scrap piece of 2x4 over a busted rung. If a ladder does not meet the manufacturer's original design criteria, it is out of service, period.
The law backs this up with zero gray area. OSHA Standard 1926-1053-B16 flat out states that ladders with structural defects shall either be immediately marked or be tagged with Do Not Use, and shall be withdrawn from service. This is a strict legal mandate. It's not a friendly suggestion, and let me tell you, compliance officers do not give warnings for this.
So how do we actually handle this out in the dirt? OSHA gives us 3 approved isolation methods. Number 1, slap a highly visible, durable red Do Not Use tag on it right away. Number 2, mark the ladder in a bold, unmistakable way that screams defective to anyone who even glances at it. Or number 3, physical blocking. Literally bolt a sheet of plywood across the rung so no one walking by can possibly step on it. Take the choice out of their hands.
Let's look at how this ties into supervisor responsibilities. Based on actual OSHA citation data, there are 4 main extension ladder violations that inspectors are constantly writing tickets for in the field. Failure to extend the ladder 3 feet above the landing, using ladders for the wrong purpose, failure to mark and pull defective ladders, and carrying loads that cause a loss of balance. This is exactly what compliance officers are hunting for when they walk onto your site.
And honestly, those citations, they stem directly from the common worker mistakes that drive every seasoned foreman completely crazy. Stuff like using a stepladder folded up and leaned against a wall like an extension ladder. Don't do that. Or standing on the top step, the top cap, just to get an extra few inches of reach instead of just climbing down and grabbing a taller ladder. Or carrying heavy tools in your hands up the rungs instead of utilizing your tool belt.
To avoid those citations and, actually stay safe, you've got to master the basic math of a safe setup. It's the 4-to-1 ratio and the 3-foot extension rule. For every 4 feet of height to your top support point, the base of the ladder needs to be 1 foot out from the wall. Pretty simple. And those side rails must extend at least 3 feet above the upper landing surface. That gives you the stability and that vertical handhold you absolutely need to step off safely.
Speaking of vertical handholds, keeping your balance means maintaining 3 points of contact at all times. That means 2 feet in one hand or 2 hands in 1 foot. If you are carrying a stack of shingles or a bunch of heavy tools in your hands, you've just sacrificed your stability. Put the small stuff in a tool belt, or better yet, use a hoist line to pull your heavy materials up after you've safely reached the landing.
All right, I've got a massive pro tip for the supervisors running the show. Take the guesswork out of load ratings for your crews entirely. Standardize your whole job site inventory on Type 1A ladders, which hold 300 pounds, or Type 1AA ladders, which handle 375 pounds, and make them all fiberglass. Doing this completely eliminates electrical conductivity hazards, and it guarantees those ladders can easily handle heavy guys wearing full tool belts and carrying dynamic loads.
So the crucial question I want to leave you with right now is this.
Would you really bet your life or your crew's lives on a cracked rung or a skipped 60-second inspection? Because when gravity takes over, there are no second chances. Make those daily inspections a non-negotiable habit on your sites. All right, grab your gear, guys. Let's head over to the stairwells and take a look at the requirements for temporary stairs.
Section 7, Temporary Stairways. So, picking up right where we left off, if a ladder gets a Do Not Use tag slapped on it during your morning inspection, we need alternative access, like immediately. You can't just leave your crew stranded up there or let them improvise. Under OSHA Subpart X, anytime there's a break in elevation of 19 inches or more and no ramp or hoist is provided, we absolutely have to provide a proper stairway or ladder. And that brings us to the importance of temporary stairways out there in the field.
Stairways, the safe choice for frequent access. Look, when we talk about moving guys between levels, especially with heavy foot traffic, stairways are always the safe choice. Think about your crews out there for a second. You've got guys hauling heavy tool belts, carrying materials, moving fast. Relying purely on portable ladders for a high-traffic transition point, man, that's just asking for an accident. That's why OSHA steps in and requires proper temporary stairways to keep everyone moving safely and efficiently. If the permanent stairs aren't poured or installed yet, we step up and build a temporary route. And here's the kicker. It needs to be built tough enough to support 5 times its intended load.
What you're seeing here brilliantly illustrates a solid field solution. As a foreman doing your ground-up walkthrough, a properly constructed wooden temporary stairway is exactly what you want to see. Notice the uniform construction, the sturdy stringers, and those rails securely in place. Compare that in your head to a single portable ladder leaning against a trailer. A stairway like this provides essential stability. Your guys can walk down naturally, facing forward, with a secure handhold. It completely changes the safety dynamic of your site.
Okay, let's talk geometry, because OSHA is incredibly specific here. Notice that angle highlighted in green? Temporary stairs must be installed between 30 and 50 degrees from the horizontal. We cannot just lean stringers at whatever angle is convenient for the space we have, right? This strict 30 to 50 degree geometry is entirely necessary to prevent the descent from being dangerously steep or, on the flip side, way too shallow. It keeps the center of gravity directly over the worker's feet where it belongs. If you push past that 50-degree mark, it stops functioning like a stair and literally starts acting like a highly dangerous, non-compliant ladder. 1/4 of an inch. Now, what's really interesting here is this single measurement. That is the absolute maximum variation allowed for riser heights and tread depths in any single stairway system. I need to aggressively highlight this for you, because I see this violated on job sites all the time. You might think, a half-inch difference on a bottom step is no big deal. But man, it is a massive hazard. Here is the science behind it. The human brain subconsciously programs your stride length and foot lift height on the very first few steps you take. So if step number 4 is suddenly half an inch taller than the rest, a worker's toe catches and they go down hard. Keep those measurements uniform.
Stairway landing requirements. Let's move to landings and see how this builds our safe access route. You can't just build a 20-foot staircase straight up into the sky. OSHA requires a landing platform every 12 feet or less of vertical rise. Long climbs require rest platforms, and honestly, they provide a break in the momentum if someone trips. Those landings have to be at least 30 inches deep in the direction of travel, and a minimum of 22 inches wide. And here is a crucial pro tip for your framing stages. If a door or gate opens directly onto that stairway platform, the swing of the door can never, under any circumstance, reduce the effective width of that platform to less than 20 inches. A door swinging out cannot pinch a worker against the rail or push them down the stairs. Which brings us to a transition in our walkthrough and a major job site hazard. Look closely at these skeleton metal pan stairs. We see this all the time in commercial multi-story builds. The metal frames get installed, but they are just sitting there, waiting for the concrete fill to be poured to create the actual steps. Would you let your crew walk on this? I want you to really look at those deep, empty metal pans with those sharp raised lips. And I'll ask you directly, would you let your guys walk on that? The answer has to be a hard, non-negotiable no. OSHA absolutely prohibits foot traffic on unfilled pan stairs, except during the actual construction of the stairs themselves. Those exposed metal lips are the ultimate trip hazard, especially when guys are carrying materials and literally can't see their feet.
Securing pan stairs. So, what is the practical field solution? If we need to use that stairwell before the concrete trucks arrive, we have to temporarily secure it. Temporary treads made of wood or another solid material must be cut, placed in the pans, and secured. But here is the critical detail. They must be filled to the absolute top edge of the pan, not half an inch below, flush to the top edge to entirely eliminate that tripping hazard.
And listen, as the supervisor, this is on you to monitor. If hundreds of heavy work boots wear down that temporary wood below the pin edge over a couple of weeks, you got to pull them out and replace them. Handrails versus stair rails. Know the difference. Now let's clear up one of the most confused topics for workers and, yeah, even some supervisors out in the field. When we're doing our OSHA Subpart X inspections, people constantly mix up these two terms. They sound similar, but they serve two entirely different critical safety functions on your stairways.
Let's break them down side by side. First, the handrail. A handrail is exactly what it sounds like. It is the handhold. It provides an adequate grip for an employee to avoid falling backwards or slipping down the stairs. It sits between 30 and 37 inches high, and temporary ones need at least 3 inches of clearance from walls or other objects. Why? So a worker wearing thick work gloves can actually wrap their fingers all the way around it. Now on the flip side, the stair rail. A stair rail is essentially your fall protection guardrail. It runs along the unprotected open sides of the stairway, and it sits higher, between 36 and 42 inches. Its job is to prevent a worker from falling completely over the edge of the staircase. Now, the top edge of a stair rail can sometimes serve double duty as a handrail if it happens to be perfectly between 36 and 37 inches, but the crucial point is that both systems must be built tough enough to withstand 200 pounds of force applied in a downward or outward direction. The 4 risers rule. So when exactly do you need to spend the time and lumber to install these rails on temporary stairs? I'll give you a super easy memory trick for the field. It's the 4 risers or 30 inches rule. If a temporary stairway has 4 or more risers, or if it rises more than 30 inches, whichever comes first, it absolutely must be equipped with at least 1 handrail and a stair rail system along every unprotected side. Commit that to memory right now. 4 risers or 30 inches. That is your trigger for mandatory rail installation. Supervisor inspection duties. As we wrap up our walkthrough on stairways, let's lock in your daily supervisor inspection duties. Before your crew hits the stairs in the morning, you must eliminate any slippery conditions. Ice, mud, grease. Get it cleaned up. You have to remove hazardous projections. Usually that means scanning for protruding nails left over from the framing crew. You need to physically shake those rails to ensure they still meet that 200-pound force capacity. And finally, under Subpart X, temporary spiral stairways are completely banned. Employees must never use non-permanent spiral stairs. The extreme tripping hazards from irregular tread depths, plus the physics of an angular descent, it's just way too dangerous. What does the job site injury data tell us about our next steps? So, we've walked the site, we know how to properly tag our ladders, and we know exactly how to construct, measure, and inspect our temporary stairways to keep compliance tight and the crews safe. But what happens when these specific rules are ignored, or a worker takes a shortcut? What does the job site injury data tell us about where our biggest blind spots really are out there?
All right, so picking right up from those staggering injury and violation statistics we just covered, we all know exactly what's at stake here. I mean, we're talking over 100 fatalities a year and literally thousands of injuries just from ladders alone. And honestly, that is exactly why we don't just memorize OSHA Subpart X to pass some exam. We have to actually live it out there on the site. So let's dive straight into this final section. We're going to transition smoothly from looking at what goes wrong to how we actively, aggressively prevent those failures on our job sites every single day.
Look, guys, I've been walking real construction sites for over 20 years now. I've seen the aftermath of a ladder kickout, I've seen stairway collapses, and I can tell you firsthand, those citations we just talked about, they aren't just paperwork. They represent broken bones, ruined livelihoods, and honestly, much worse. Knowledge is, without a doubt, your absolute best fall protection. What we're about to lock in right now are the golden rules. These are the practices that separate the true professionals from the amateurs. Let's bring it all home and make sure you've got the practical, field-tested knowledge you need to keep your crew safe.
Okay, so the crucial part here is locking in these non-negotiables. I always like to anchor these in memory by grouping them into the rule of 3s. First up, maintain 3 points of contact at all times. No exceptions. That means 2 hands and a foot or 2 feet and 1 hand, period. Second, if you're using a portable ladder to get to an upper level, those side rails have to extend at least 3 feet above that upper landing surface. Third, never, ever step on the top cap or the step right below it on a step ladder. It completely wrecks your center of gravity. And finally, always face the ladder when going up or down. Keep your belt buckle firmly between those side rails. If you find yourself reaching so far that your buckle crosses the rail, well, you need to climb down and just move the ladder.
Now, let's see how all this builds into our actual setup protocols. 4 to 1. Listen, if you only take away one single number from this entire masterclass, make it this one right here. This is the absolute golden ratio for extension ladders. For every 4 feet of vertical height to where the ladder touches the structure, the base must be placed exactly 1 foot away from the wall. So if you're climbing 20 feet up, that base needs to be exactly 5 feet out, right? Any steeper, and you risk tipping backward. Any shallower, and that base is going to slide out right from under you. This simple, easy math prevents fatal base slide incidents every single day.
Moving on, let's talk about the equivalent critical geometry for stairways. Whenever we build or maintain stairs, whether they're temporary or permanent, they have to be set at an angle between 30 and 50 degrees from the horizontal. That right there is the sweet spot for a natural, safe human stride, especially when you're carrying heavy tools. Plus, any stairway with 4 or more risers, or one that rises more than 30 inches, absolutely has to have a stair rail system. In that top rail, it needs to be at least 36 inches high and capable of withstanding 200 pounds of force in any downward or outward direction. No cutting corners on that one.
Now, here's a little detail that trips up a lot of seasoned crews: uniformity. There can be no more than a 1/4 inch variation in any stairway system's riser height or tread depth. You might be wondering, why is OSHA so ridiculously strict about 1/4 inch? Well, it all comes down to muscle memory. Think about it. When your crew is humping 50 pounds of gear up a flight of stairs at 6 a.m., they aren't staring at their boots. They're looking at where they need to go. Their brain automatically anticipates the exact same lift for every single step. A variation greater than 1/4 inch, that becomes a massive, completely invisible tripping hazard.
Speaking of temporary stairs, pan stairs are something you see constantly in commercial construction. But as supervisors, you have to know that these simply cannot be used safely unless they are properly secured in place and completely filled to the top edge with wood or some other solid material. If you let a crew walk on unfilled pan stairs, I guarantee their boots are going to catch that steel lip and you are going to have a severe face-first fall on your hands. It's just a matter of time. Secure them, fill them, and replace any worn landings immediately.
Okay, let's put this knowledge to the test, all right? Let's run a real-world job site scenario. Imagine you're walking the site and you spot a worker carrying a heavy toolbox in one hand, climbing up a portable ladder to a roof. You also notice the ladder extends exactly 1 foot over the roof landing. Take a second. Really picture that situation in your mind's eye. What are the specific hazards that you, as a safety leader, need to spot and stop right that second?
Well, if you caught both of these issues, awesome job. First off, that ladder only extending 1 foot, that is a direct violation of 1926 Subpart X. It has to extend at least 3 feet above the landing so the worker actually has something to hold onto while transitioning onto and off the roof. If pushing it up 3 feet is physically impossible, it's got to be rigidly secured at the top with a grab device installed. Second, that heavy toolbox. Carrying a heavy load in one hand completely destroys the 3 points of contact rule we just talked about. It also completely throws the worker off balance. The correct protocol here? Climb that ladder empty-handed using your 3 points of contact and use a rope or a hoist line to pull that heavy toolbox up once you are safely secured on the landing.
Let's throw another practical quiz question at you, focusing heavily on your daily responsibilities. It's 6:30 a.m. You're doing your required pre-shift inspection of your crew's equipment, and you come across a fiberglass extension ladder with a severely cracked side rail. What is your immediate, non-negotiable action?
Honestly, there are 2 ways people handle this. There's the lazy, dangerous reaction that gets people killed, leaving it leaning against the wall, or just hollering to the guys, "Hey, be careful on that one today." That is a massive OSHA violation and, frankly, a moral failure as a leader. Compare that to the strict correct action required by the standards. You must immediately tag it with a sign clearly stating "do not use" or "defective," and you have to physically withdraw it from service. Move it completely away from the work area so nobody accidentally grabs it when they're in a hurry. It stays completely out of service until it is properly repaired to its original design criteria or just completely destroyed.
Now, throughout this whole explainer, we've thrown around the phrase competent person quite a bit. OSHA mentions it constantly, but I really need to clear up a massive misunderstanding in our industry right now. Taking a masterclass like this one gives you incredible life-saving knowledge, absolutely, but it does not automatically make you a competent person in the eyes of OSHA. The true definition requires the knowledge to identify hazards, yes, for sure, but the crucial second half is that you must have the actual authorization to take prompt corrective measures to eliminate them. Only your employer can designate you as a competent person because they literally have to hand you the authority to stop work, buy new equipment, or shut down a dangerous operation on the spot. So, to sum this all up, this is the core daily routine every single worker and supervisor must follow to ensure we all actually go home to our families at the end of the day. Number 1. Inspect your ladders and stairways before every single shift. Number 2. Set up for success. Secure your ladders, use that 4-to-1 ratio, make sure you're on firm level ground, and confirm stairways have the right angles and handrails. And number 3. Climb safely. Face the ladder, respect those 3 points of contact, and never carry loads that throw off your balance. I know it sounds simple, but doing the simple things flawlessly every single day is what actually saves lives.
Hey, I really want to congratulate you on completing this masterclass. You now possess the supervisor-level knowledge required to spot the hazards that most people walk right past. But remember, knowledge without action is useless. Be a safety leader on your job site, protect your crew, speak up when you see a bad ladder setup, and take the time to build safe stairways. If you found this field training valuable, please subscribe, like, and share this explainer with your teams. It really helps us keep bringing you these practical safety masterclasses. I'm going to leave you with this final thought for your next shift. When you walk onto the site tomorrow morning, are you just working there, or are you actually leading it? Stay safe out there.